Welcome to the next video, and in this video, this is for beginners chemistry. So we will be looking at the atomic structure and how to draw the atoms of the structure of different atoms for the first 20 elements of the periodic table. So the atom is made up of three fundamental particles, right? Protons, neutrons, and electrons. But it is composed of a central nucleus, and which we are going to show by the first circle. So each circle represents something else. So the first circle here, that is our nucleus. So every atom is composed of a central nucleus, and inside of the nucleus you will find the protons and the neutrons. So you will put a P to represent protons and an N to represent neutron. Now around this shell, around the nucleus, we will have the shells, and the shells now will contain the electrons. So the atom consists of a central nucleus surrounded by shells. The protons and the neutrons are in the nucleus, and then the shells we have the electrons. Now each shell can hold a certain amount. So the first shell will hold 2 electrons, the second shell will hold 8. At this level, for the third shell, we say we are going to use 8. It can hold 18, but for this level and for the CSEC exam, we are using 8. So the first shell, 2 electrons, the second shell holds 8, the third shell holds 8 as well. So this is the basic construct of your atom. Now, depending on the type of element, you may just use 1 shell, 2 shell, or 3 shells. So before we draw the atoms for different elements, we need to know how many neutrons and protons is associated with the element. So if you look in any periodic table, right, you will see the symbol for each element and 2 numbers as well. The number at the top will be the mass number, and the number at the bottom of the symbol will be the atomic number. So there are 2 numbers associated with each element, a mass number and an atomic number. So the atomic number is always at the base of the symbol, and the mass number is at the top, right? And the mass number is always the larger number. So if you check a periodic table and you see the larger number down here, that's the mass number. So the mass number is always larger than the atomic number. And the reason for that, the mass number is a sum of the number of neutrons. The N here is for neutrons. So the mass number is a sum of the number of neutrons as well as the protons, whereas the atomic number is the same as the protons, right? So if you want to find the mass number on exam, so as a little quiz, if a teacher gives you the number of neutrons and the number of protons, and you want the mass number, all you have to do is add the 2 of them. If you have the mass number and the atomic number, you can find the number of neutrons. So mass number minus atomic number gives you the number of neutrons. So for example, the atom of sodium, right? We know the mass number is 23 and the atomic number is 11. That means if you want to find the number of neutrons, it would simply be 23 minus 11, and that would be equal to 12. So we know that the atom of sodium, it has 12 neutrons and 11 protons. The number of protons and electrons in the atom are equal. So the atomic number, the number of protons, and the number of electrons in an atom are equal. So that is so the atomic number is equal to the number of protons, which is also equal to the number of electrons. Alright, so we're just going to work a few examples. So the first one is phosphorus. Phosphorus has 15 protons and 16 neutrons. So if we want to work out the mass number, so we said that the mass number is the number of protons plus the number of neutrons. So it has 15 protons and 16 neutrons. Therefore, the mass number for phosphorus is 31, and the atomic number is 15, because the atomic number and the proton number is the same. So the symbol for phosphorus is P. Therefore, we would have 31 at the top and 15 below. Alright? Let's take a look at aluminum. Here, I give the atomic number and the mass number. So if I want to calculate the number of neutrons, right, it would be the mass number minus the number of neutrons, number of protons. Alright? So number of neutrons is the mass number minus the number of protons, which is the same as the atomic number. So the mass number is 27 for aluminum. Atomic number, again, it is the same as the number of protons. So it is 27 minus 13. So aluminum has 14 neutrons. And as you can see, if you add the number of neutrons and the number of protons, you will get back 27, which is the mass number. So whenever you want mass number, you just simply add the number of protons and the number of neutrons. When you want the number of neutrons, you will be given the mass number and the number of protons. You just subtract the number of protons from the mass number and you get the number of neutrons. Alright, here again, you get the number of protons and the number of neutrons. So the mass number would be 16 plus 16, and that is 32. And that's it. Alright, so you know how to calculate mass number, number of neutrons, right, based on the data you are given. So now we're going to draw the structure of certain elements, the atoms. Okay, so we're going to start off with sodium. This symbol for sodium is Na. We know that the atomic number is 11, the mass number is 23. So remember we said that the atom has a central nucleus, right? It will have the number of protons and the number of neutrons. Now, I told you earlier that the atomic number and the number of protons are the same, which is 11. Now, to get the number of neutrons, you just subtract the atomic number from the mass number. That means sodium has 12 neutrons. Now, that comprises the nucleus. Around the nucleus, we will have our shells. Based on the element, you may have a different amount of shells for its atom. So, it will be based on the amount of electrons that determines the amount of shells. So here, sodium has 11 protons. So once the atomic number is 11, that means sodium has 11 electrons. The E with the dash, that's the symbol for the electron. So sodium has 11 electrons. And remember our rule now, the first shell, so the first shell, it will hold 2 electrons. The second one, it will hold 8, and the third one can hold a maximum of 8 as well. Alright, so sodium has 11 electrons. The first circle around our nucleus, that's the first shell. We cannot put 11 electrons on the first shell, because the rule is that the first shell, you must only put 2 on it. Alright, we can use an X or a dot to represent our electrons. So sodium has 11, but on the first shell, we cannot put more than 2. That means we need a second shell. Now the second shell, it can hold a maximum of 8. So we put 2 on this one. The second one can hold a maximum of 8. So we can put 8. So 2 electrons on the first shell and 8 on the second shell, that's a total of 10. But we must put 11. But you have to pay attention, we cannot put more than 8 on the second shell. So we have to move on to a next one. Right? The third one, we can put a maximum of 8, but all we have for sodium is 1 more. Alright? And that comprises our atom for sodium. It has 11 electrons. We need to put them on the shells. The first one can only hold 2, a maximum of 2. So put the 2. That leaves us with 9 electrons. But our second shell cannot hold 9. It can hold a maximum of 8. So 8 from 9 leaves us with 1. So we need a third shell. The third shell can hold a maximum of 8, but we only have 1 remaining electron, so we just put 1 on it. So that's the atomic structure for sodium. Now if we look at how the electrons are arranged on the shells in sodium, we have 2 electrons on the first shell, then we have 8 electrons on the second shell, and 1 on the third shell. So this arrangement is called the electronic configuration, EC for short. So that is electronic configuration. So the electronic configuration of an atom, it is just telling you how many electrons are on each shell. So the first shell, it has 2 for sodium, the second one has 8, and the third one has 1 electron. This is not the electronic configuration, it is telling you how much the maximum amount of electron each shell can hold. So if you're asked for the electronic configuration of sodium, right, you will not put 288. This is telling you the amount of electrons each shell can hold. In sodium, the first shell has 2, the second shell has 8, the third one has 1 electron. So that is the electronic configuration, 281. So we're going to work on the next example. Okay, so let's try carbon. So the atomic number for carbon, so the symbol is C, atomic number 6, mass number 12. So the number of proton would be the same as the atomic number, which is 6. The number of electron is the same as the atomic number, so it would be 6 as well. And the number of neutron would be the mass number from the atomic number, so that would also be 6 as well. So starting with the nucleus with the protons and the neutrons, 6 protons, 6 neutrons. The first shell, so we have a total of 6 electrons. The first shell can hold 2. So 2 from 6, we have 4 electrons remaining, so we need a second shell, right? And the second shell, we will put our remaining 4 electrons and we are finished. Sodium had 11, carbon only has 6, so we have no need for a third shell. The only time you will need a third shell is after you have completed the second shell. So you put 8 on it and still have some remaining. In this case, carbon only has 6. So unless you have more than 10 electrons, you will not need a third shell. Alright? And this is how you will do it over and over. So that's just it. So we'll work one last example. So the next one now is calcium, and as you can see, sometimes the number of protons and neutrons are the same, but not all the time. So atomic number is 20, that means proton and electron is 20. The mass number is 40, so 20 from 40 gives us 20 neutrons. So inside the nucleus, we will have our 20 protons and 20 neutrons. So our first shell, we will put on our 2 electrons. The second shell, we will put on 8. 2, 4, 6, 8 electrons. So 8 on the second, 2 on the first, we're going 10 electrons. That means we still have 10 more. So we will draw a third shell. And we are going to put on 8. 2, 4, 6, 8. So 2 on the first shell, 8 on the second, that's 10. 8 on the third, that is 8. 8 on the third, that is 18. Right? But it's 20. Remember we said we're working that the third shell holds a maximum of 8. That means we need another shell. Right? And you put 2 electrons on that one. Alright, so that's the atomic structure for calcium. The electronic configuration, that would be 2 on the first shell, 8 on the second shell, 8 on the third shell, and 2 on the fourth shell. And for CSEC, we're looking at the first 20 elements, so this is the farthest you will go in terms of the atomic structure, because calcium is the 20th element. So doing atomic structure is not hard, right? Just calculate the number of neutrons from the mass number and the atomic number and fill out the nucleus. Then you will just arrange the electrons accordingly. 2 on the first shell. If you have more, put it on the second. If you have more than 8 to put on the second, you will go to a third shell. And if you have more than 8 to put on the third shell, then you go to the fourth shell, right? And so that's our video on just drawing atomic structure. So this is basic chemistry, right? Introducing you to drawing the structure of atoms, alright? So that's it for this video. In the next one, we'll continue from here to show you how atoms can form ions, both positive and negative ions, alright? So remember to like, subscribe, and share.